Most developers prompt AI like it's a search engine. They type "fix my code," or write a function, and they get back junior level output, generic, wrong version, untested. Then they blame the model. Here's the truth: the people getting senior level code out of these tools aren't using secret models. They're using better prompts. So in this video I'm handing you 10 concrete, copy-pasteable prompt templates, one each for debugging, refactoring, tests, SQL, code review, explaining legacy code, regex, error messages, boilerplate, and commit messages. Every one is a reusable template plus a real before and after on actual code. Steal them, paste them, and watch the output snap from junior to senior. Let's go. Prompt 1, Debugging. Most people paste an error and type "why is this broken," and the model rewrites half your file guessing at what you meant. Here's the template instead. Here is a function and the error it throws. Explain the root cause in one sentence, then give the minimal fix. Do not rewrite unrelated code. Then you paste the function, the full traceback, and your language and version. 3 things make this senior. 1. You ask for the root cause in one sentence, which forces a real diagnosis instead of a vague lecture. 2. Minimal fix, so it changes the one line that's actually wrong, not your whole style. 3. Do not rewrite unrelated code. That single sentence stops the model from silently reformatting everything and hiding the real fix. Watch it work. Here's an average function that divides sum by length. The traceback says 0 division error, division by 0. The model comes back, root cause, length of nums is 0 for an empty list, so the division fails. Minimal fix, guard the empty case and return 0.0. One line changed, everything else untouched. That's the difference between a junior answer and a senior one. Prompt 2, Refactoring without breaking things. The scary part of asking AI to clean up code is that it quietly changes behavior. This template locks that down. Refactor this for readability without changing behavior. Keep the public signature. List each change and why in one line. Then paste the code. The power is in the constraints. Without changing behavior tells it this is a refactor, not a rewrite, same inputs, same outputs. Keep the public signature means the function name and its arguments stay identical, so nothing that calls it breaks. And list each change and why forces it to justify every edit, which makes review trivial and catches it red-handed if it tried to sneak in a behavior change. Here's a messy function that loops, checks active equals true, and appends names to a list. The model returns a clean version, same name, same argument, but now a single list comprehension, and it dropped the redundant equals true. And it tells you exactly that, one line per change. Same behavior, half the code, and a paper trail. That's a refactor you can actually trust. Prompt 3, Writing tests. Ask for tests and you'll usually get one happy path assertion that proves nothing. This template gets you real coverage. Write tests for this function covering the happy path, edge cases, and error cases. Use PyTest. List the cases first, then the code. 2 things matter here. Naming the 3 categories, happy path, edge cases, error cases, forces the model to think about the inputs you didn't. And list the cases first, then the code means you get a plain English checklist you can eyeball before you trust a single line of test code. Watch what it surfaces. For our average function it lists, happy path, a normal list, a single element, and, here's the one you forgot, the empty list. It writes a test asserting that average of an empty list returns 0.0, which is exactly the edge case that crashed us 2 prompts ago. The model found the hole in your own thinking. That empty input case is the whole reason to ask for tests this way. Prompt 4, SQL. Most people describe a query in vague English and get back something that silently drops rows. Give it the schema and be explicit. Given this schema, and you paste your tables, write a query that does this specific goal. Explain the join and any null handling. Use standard SQL. Pasting the actual schema is what stops the model from inventing column names. And explain the join and any null handling is the senior move, because joins and nulls are exactly where queries go wrong. Here's the goal: every customer with their total spend, including customers who have never ordered. The model writes a left join from customers to orders, wraps the sum in coalesce to turn null into 0, and groups by customer. Then it explains why a left join keeps customers with no orders, but their order total comes back null, so a plain sum would be null too. Coalesce with 0 fixes that. That one null node is the difference between a report that shows every customer and one that quietly hides your newest ones. Prompt 5, Code Review. Ask a model to review code and it'll drown you in style nitpicks while missing the actual bug. Point it at what matters. Review this diff like a senior engineer. Flag bugs, security issues, and edge cases. Rank by severity. Skip style nits. Like a senior engineer sets the bar. Flag bugs, security issues, and edge cases tells it the 3 things you actually care about. Rank by severity means the scary stuff floats to the top. And skip style nits kills the wall of use a better variable name noise. Here's a login function that builds a SQL query with an F string, dropping the username straight into the text. The review comes back ranked. Critical, security, that's a SQL injection, use a parameterized query with a placeholder instead. High, bug, the password is never actually checked. Medium, edge case, no handling for when the user doesn't exist. 3 real problems, worst first, 0 style noise. That's a review worth reading. Prompt 6, Understanding code you didn't write. We all inherit code that makes no sense. Don't just ask what does this do, ask for the footguns too. Explain what this code does in plain English, step by step, then note any bug or footgun you see. The step-by-step gives you a readable walkthrough. But then note any bug or footgun is what turns the model from a narrator into a reviewer. It reads the code and the traps at the same time. Here's an add item function with a sneaky default, bucket equals an empty list, right there in the signature. The model explains it appends an item to the bucket and returns it, then flags the footgun. That default list is created once and shared across every call, so items pile up between calls instead of starting fresh each time. That's Python's most famous gotcha, and the model catches it while it's explaining. Now you understand the code and you know exactly where it'll bite you. Prompt 7, Regex, the thing nobody wants to write by hand, and where a model genuinely shines, because the answer is verifiable. Write a regex that matches this spec and not these counterexamples. Explain each part. Give 3 passing and 3 failing test strings. Giving it what to match and what not to match pins down the edges. And asking for passing and failing test strings is the killer move. Now you can verify the regex yourself instead of just trusting it. Here's the spec: match a US zip code, 5 digits, optionally a dash and 4 more. The model returns $\D5, then an optional group of dash and 4 digits, $. It explains each piece, then proves it, passes on 1 2 3 4 5 and on the 9-digit dashed form, fails on 4 digits, on 6 digits, and on anything with a letter. You don't have to trust it, you can read the test strings and see for yourself that it's right. That's regex you can actually ship. Prompt 8, turning a scary error into a checklist. When you hit an error you don't recognize, don't ask what does this mean, ask for a ranked plan. I got this error, and you paste it. List the 3 most likely causes ranked by probability, and the 1 command to confirm each. Ranked by probability means you check the likely thing first instead of rabbit holing on the exotic one. And one command to confirm each turns vague theories into a to-do list you can actually run. Paste a module not found error for requests, and the model comes back, most likely, it's just not installed, confirm with pip show requests. Second, you're in the wrong virtual environment, confirm with which Python. Third, it's installed for a different Python version, confirm with python-m pip show requests. 3 theories, ranked, each with a command. You've gone from stuck to a 2-minute checklist. Prompt 9, Boilerplate, done in your style. The problem with generated boilerplate is that it never matches your codebase. The fix is one example. Generate this thing with these constraints. Follow this example's style, and you paste one existing example. Output only the code. Giving it a single example is called few-shot prompting, and it's shockingly powerful. The model copies your naming, your formatting, your conventions, instead of inventing its own. And output only the code means you can paste it straight in without deleting 3 paragraphs of explanation first. Say you want an argparse command line parser with an input, an output, and a format flag limited to JSON or CSV. Hand it one of your existing parsers as the style example, and it returns a parser that matches, required arguments, a choices list for the format, a sensible default, and nothing else. No preamble, no lecture, just code that looks like you wrote it. That's boilerplate you don't have to reformat. Prompt 10, commit messages. Everybody writes worse commit messages when they're tired, and the model never gets tired. Write a conventional commits message for this diff. 1-line subject under 60 characters, then bullet points. Then paste the diff. Conventional commits gives you that structured fix, refactor prefix that tools and changelogs love. Subject under 60 characters keeps it readable in Git log and on the GitHub timeline. And bullet points capture the details without bloating the subject line. Paste a diff that adds retry logic, and it returns, feat, API, retry failed requests up to 3 times, a clean subject under 60 characters, then bullets, adds exponential backoff between retries, raises after the final attempt fails, covered by new unit tests. That's a commit message your future self will actually thank you for when you're bisecting a bug at midnight. So there are your 10 prompts. Debug, root cause plus minimal fix, don't touch the rest. Refactor, no behavior change, keep the signature. Tests, happy path, edges, and errors, cases first. SQL, paste the schema, explain the join and the nulls. Review, bugs, security, edges, ranked, skip the nits. Explain, plain English plus the footguns. Regex, passing and failing strings so you can verify. Errors, 3 ranked causes, 1 command each. Boilerplate, 1 example, output only code. Commit, conventional commits, subject under 60. And notice the meta pattern underneath all 10, every single one gives the model a specific role, surgical context, explicit constraints, and asks it to show its reasoning or verify its own work. That's the whole game. Master those 4 moves and you can write the 11th prompt yourself. If you want the full written breakdown, it's linked in the description, along with a pack of 91 ready-to-use engineered prompts if you want to go deeper. Now stop prompting like a search engine, go drive the model like a senior.